works. Okay, are we live? Okay, good morning. Today we get an interesting discussion out of the Kamailio experts talking about Asterisk and mobile. I'm not going to try reading the whole bio. It was a much too long bio to read.
Okay, thank you for coming to my talk, and it's a pleasure to be here. I really enjoyed it so far, and but please bear in mind this is my first Astricon, so honestly I'm a little bit nervous, but I think that's okay. Basically, what my main focus in the Kamailio project is actually doing IMS and mobile networks. So during my talk at Kamailio World this year, we had a topic, I made a topic, make Kamailio great again at diameter. Now, who in the audience think we can do better? Anyone? Okay. Of course we can do better because we can add Asterisk to our setup. Yeah, Asterisk. Asterisk will make, of course, our IMS and VoLTE much, much better. And I will show and prove it to you why. So today I'm basically covering two topics. One topic is, of course, IMS and VoLTE and mobile networks and what it's all about. And secondly, of course, where and why do we want to use Asterisk in that setup? Okay, let me start a little bit. Probably, who of you heard the term IMS before? For me, I had the feeling like this has been a hot topic like 10 years ago, and since then it got a little bit quiet. Actually, IMS was designed as a successor of the GSM standard in 1999. So it's really been out there for quite a long time. It's been really, really, really a long, and it wasn't really even a topic, it was invented before 4G, it was actually a part of 3G already. What is IMS actually? Actually, if you look at IMS, it's a standard architecture for voice. It's really a standard architecture. It's, if you read about IMS, if you read about VoLTE, if you read about anything like that, you will get a lot of new buzzwords, which honestly, if you're new in that topic, might be really, really confusing. Because suddenly you're talking about an RX interface, CX interface, SH interface, and a whole lot of bunch of new interfaces. And of course, if you look at it initially, it might be really, really confusing. But in the end, everybody is just boiling with water. So all we have is basically we have zip. Okay, surprise, we can do that. We've got diameter. And diameter is actually nothing more than basically an evolution of radius. So you find a lot of people who actually can deal with radius. So diameter just being an evolution of radius. So that's not that black magic anymore. And then, of course, you might end up with some SS7 and stuff like that. But it's really nothing to be afraid of. And the design is actually based on best practices. Like, for example, everything you find in the zip standard, like for example, that you should switch from UDP to TCP on huge MTU, you will basically find all kinds of that in the IMS specifications. However, mobile operators, and this IMS topic is basically coming from mobile operators, they are really, really lazy. They really don't want to do this unless they have to. So basically, just recently, the IMS topic got more and more popular with 4G, LTE, 5G, whatever's next in mobile networks. So basically, to sum it up, IMS is best of the 90s. Really, it's something we've seen there for quite some time, and it's still there and still works. It's still great. Why is 4G so popular? Why do mobile operators want to move to 4G? If you take the total cost of ownership for a mobile network, make a guess how much a 3G network, not 4G, but 3G, is compared to 2G, to the previous number. Just make a guess, anyone. It's actually a quarter of the price. A quarter of the price if you go from 2G to 3G UMTS. So now we've got a brand new technology. We've got 4G LTE. Anyone a guess? What's the difference between 3G and 4G? A 10? Okay. Actually, it's again 5 times less. So you really got, as a mobile operator, you got really huge savings. And I have to admit that probably these numbers are already outdated because the prices for mobile networks are going down, down, down. Just to give you an example, like 3 years ago, since I've been working on mobile networks, I've been working on IMS, I wanted to purchase a mobile network cell for my lab office. And 3 years ago, I was searching, I was asking different vendors, can I get a small network cell for my office, for my lab? And the first offers were like 40,000 euros. And I thought, okay, small company, no, I don't need that instantly. And only a year later, I come across a small network cell, which was just 9,000 euros. So, okay, that's the one I have in my office now. And if you look even further, I think probably by the end of the year we might see the first small network cells who actually have a great coverage of 1 square kilometer for about 1,000 euros or $1,000, something in that direction. So the prices are really, really going down. There's one other topic that's a huge concern for mobile operators. There's one thing that I would say money can't buy. Anyone, any idea? Spectrum. Exactly, that's the right answer. If you look at the spectrum usage on a 3G network or even 2G network, then you will actually see that 40% of the spectrum is actually used for voice. 40%. So basically you've got 60% of the spectrum you can use for internet and other services, and 40% is already taken for voice. Okay, good. If you go for 4G, for basically modern mobile networks, how do you think this number will change? What? 98%. Well, not quite. But anyway, it's going to be 10% for voice. So as a mobile operator, you've got huge savings. You've got really, really huge savings on your mobile network. The network gets cheaper. But, okay, now I've got a cheap 4G network. Great. It's really great. We've got a 4G network, everything's fine. But there's a catch. If you're on 4G, suddenly everything is IP. On 2G, 3G, you still had the capabilities for voice. But on 4G, it has to be over IP. There's no real voice service. It has to be voice over IP. And this is basically why VoLTE, IMS, and mobile networks are really getting a huge topic. Because as a mobile operator, you have to implement a voice service. And of course, you've done IMS. It's something we learned in the past. That was cool, that was great. But it didn't really take off. But shit, now we need a voice service. We really need a voice service. So, okay, of course, the natural choice for 4G, 5G, and beyond is IMS and VoLTE. So basically, to sum it up, okay, we've got limited spectrum. Every time I talk to mobile operators, they basically tell me, well, okay, well, if we move more services to 4G, well, great, then we can deallocate spectrum for 2G, 3G services, because more services on 4G. So they're really fond about moving to 4G. And one thing that I totally didn't cover so far is actually the network efficiency. Like basically the network itself gets way more efficient if you move from 3G to 4G. With the same spectrum, you can do a lot more. The network gets cheaper. So what else do I have to say why you need 4G? Actually, that's about it. Every operator wants to run 4G. If you would build a new network, it will be 4G and nothing else, simply because the total cost of ownership. So, back to the topic. I hope I all convinced you that you all need a 4G network. Who of you is using Kamailio actually? And probably most of you wouldn't see Kamailio as a mobile network component, right? Well, basically, we are using Kamailio for our IMS core, which is used for VoLTE, basically because it's a rock-solid zip proxy. It simply works, it's really stable, it's really fast. It's really the best choice we could get for running zip and voice. On the other hand, there was the Open IMS core, who was originally implemented by the Fraunhofer Institute. And okay, this was a science project. This was a science project which was actually mostly focusing on test beds, research and development, and not really for production use. On the other hand, the Open IMS core from the Fraunhofer Institute was really standards compliant. So it's really, really close to the standard. It wasn't stable, but for test beds and R&D, that's fine. But it was really, really standards compliant. And as a matter of fact, it was also based on the Zip Express Router project, which is the same source as the Kamailio project is based on. So that's a great starting point. So basically in 2011, we started merging the Open IMS core and Kamailio. And I have to admit it has been quite a journey, because it hasn't always been easy. And of course, if you tell anyone you want to do IMS, then yeah, right. That didn't work in the 90s. Why should it work now? But it's really taking off at the moment. Okay. Why is standards compliance such a huge topic? Why? It's actually quite simple. Just imagine you have a driver's license in one country, in the US maybe. And imagine that all the rules you have for driving cars would apply to every country, everywhere in the world. It wouldn't matter if you're in the UK or if you're in the US, you would always drive on the right side of the street. And all the signs are the same. So basically, the cars work everywhere in the world. You can use basically, you can drive wherever you want because the rules are the same. Basically everything fits together. So that's why actually standards compliance is really a huge topic. And as a Kamailio project, of course, we're focusing on the voice part, clearly. Voice is our topic. And okay, we're doing diameter by now, but the main focus is somehow still on voice. But as a Kamailio project itself, we've integrated with lots of other network components. For example, from Nokia Siemens mobile networks, from Ericsson, from basically, I would say by now we have almost all, we've integrated Kamailio with all big vendors. So that's why standards compliance is really a huge topic. However, Kamailio is a great foundation if you want to build anything pure zip. So basically all the IMS core network elements, that's a perfect match for Kamailio. You can build the proxy, you can build interrogating, you can build basically all really the basic core network functions. Every component that speaks zip, you can do with Kamailio. One of the great additions we made last year was actually that we added a lot more in terms of diameter, but still everything is really zip only. Okay. However, there are some parts missing in Kamailio. So we simply don't have any media handling apart from probably relaying a little bit RTP and maybe a little bit sRTP to RTP translation, but that's basically about it, what you can do with Kamailio and friends. And everything beyond zip is literally missing in Kamailio. I know this is probably a confusing picture. And this picture basically describes all the network components we have in an IMS setup. So we've got a proxy, which is basically some sort of gatekeeper. We've got a load balancer, which we call interrogating CSCF. We've got a registrar, which is a serving CSCF. We've got all kinds of network elements. Let's take a closer look at the proxy CSCF. The proxy CSCF in our IMS mobile network is basically some sort of a gatekeeper for your mobile network. It's the first stop. If you don't use the proxy CSCF, you cannot use your mobile network. You need to check if the message is valid. You need to add some missing trusted information. You basically have to align everything that's coming into your network with your own standards. Probably you also want to do some quality of service bits on the proxy CSCF, because typically you would locate a proxy CSCF close to the actually subscriber, so you can actually connect to the network cell. But, okay, so actually it's a good choice to use Kamailio here. But, okay, Kamailio is no back-to-back user agent, and probably if you want to build your network, then you want to add a certain level of security. And if you take a standard mobile handset like this one, then you will need to do transcoding. That's somehow mandatory, and we cannot do that with Kamailio. So originally, like basically in the beginning of the project, we've been using the Zip Express Media Server, or ZEMS for this part. Does anybody know ZEMS? Yeah. But basically, ZEMS does quite a good job as an SBC, and it adds transcoding, because actually we've added that. But somehow, even though the developers of the project don't admit that, I tend to say, I don't want to call the project dead, but like in the project we've seen in the last year one commit, which was basically a bug fix or something like that. So yeah, while it still works, I honestly don't feel comfortable with that. Due to this reason, we've been looking, what else can we do? What else can we use? And okay, of course, if we want to have a back-to-back user agent which can do a little bit transcoding, then of course, besides SEMS, there are some choices we can do. Initially, we tried FreeSwitch. And for some use cases that worked, but other use cases were a complete disaster. And we even tried to hack the zip stack on FreeSwitch to make it work, but we literally failed. And we didn't even try to add the mandatory codecs we need for voice over LTE to FreeSwitch, because if everything else fails beforehand, then there's no point. Then we started looking at Asterisk 13. And actually, to my surprise, Asterisk 13 worked really very well out of the box. Everything worked. I was really surprised. If you take the standard packaging on Debian 9, you even get the mandatory codecs for VoLTE pre-packaged. I was like, wow, this is great. And every use case we have for a back-to-back user agent really worked instantly with Asterisk. We've got certain requirements for Asterisk if we use it in conjunction with our proxy CSCF. It has to be some sort of back-to-back user agent, because we want to separate the signaling. We need to remove anonymized headers. We want to anonymize SDP. And unfortunately, luckily, we need to do transcoding. Don't ask me why, but basically, the mobile network guys decided to use an AMR codec, which is doing a quite good job on mobile networks, but besides of that, you need to take care of patterns, which is a little bit pain in the ass sometimes. One thing that you need to know, if you want to use Asterisk in such setup, you have to use PJZip. There's no way around PJZip in this case. The reason for this is quite simple. Wait, let me just quickly. If you take a look at my basic picture here, then, for example, if I'd have a VoLTE phone here to make a phone call, I would dial my number, it would go to my proxy CSCF, I would send it to the Asterisk as a session border controller or back-to-back user agent, then send it over to my IMS core to do the basic logic. And then, okay, I recognize, okay, this is actually another VoLTE handset. So in this case, basically what happens is that the call goes back to my proxy CSCF, which might be the same because I'm on the same network cell, and it goes back to my VoLTE phone. And it goes a second time through my Asterisk back-to-back user agent. So for legacy Chen Zip, this is a huge problem, because it will basically say, okay, this is a loop. While if